Hey, what's up guys? My name is Achano. Welcome back to my game engine series. So last time we took a look at creating windows and we used GLFW to actually create the window for our game engine, and we talked a lot about abstractions and how we can actually abstract that window kind of logic and API outside of just sticking to a singular platform, because obviously Hazel's going to be supporting multiple platforms. So definitely check out that video if you haven't already, because that's going to be vital for this video, in which we're going to actually add events to that window. So Windows, right? Windows generates, they generate events. So anytime we move the mouse, we press a key, we close the window, we resize the window, we click a mouse button, all of that generates something called an event. If you guys haven't seen the event video where we actually implemented both the event system, but also the video before that where we planned it, definitely check it out. In fact, check out the whole Game Engine series playlist. It's really important that you guys kind of watch all the videos in order, because they help shed a lot of light as to what we're actually doing in any given episode. Anyway, the point is that in those videos, we kind of set up everything that we need to both create an event, right, and have some kind of event framework which delivers events to specific parts of our code base. And then we also created the window, which is capable of generating these events. So what we need to do now is kind of link those two systems together, and that's really what this video is going to be about. We need to be able to say that, hey, whenever an event occurs inside our window, right, we want to kind of create one of our events and dispatch it and kind of throw it out into the world. And then whatever inside our engine or later inside our game or application that actually wants to handle a certain type of event can. And a really good example, a really simple good example right now that we actually desperately kind of need is the close button. So when we hit the close button in Hazel right now, in a Hazel application, nothing happens. We click it and nothing happens. What we actually want to happen is we want to terminate the program, right? So that's what we're going to kind of implement today, as well as just being able to dispatch all of the different event types, like key presses, mouse events, window resized events, all of that kind of stuff. We're going to take a look at how we can actually set that up. So let's just go ahead and do it. Okay, so our actual application class is kind of bland right now, not much going on here. But what we actually need to do is to be able to set a callback function on the window. So inside window, what we actually made was something called set event callback, right? And this is something that comes from the abstract window, of course. And the event callback function is basically just a function which returns void and takes in an event reference as its parameter. We need to be able to set that up so that when we actually call our events, when we generate events over here, we dispatch them to that callback function. So to do that, we'll just set the event callback, and we actually need to bind it to one of the functions in here, or at least that's what I want to do. We could just use a lambda or something like that, but I'm going to bind it to an actual real function. So we're going to have a function here called onEvent, which takes in just an event as an argument like that. I'm going to go ahead and copy that, and then implement it over here. So there we go. And then we can actually use the event dispatcher that we created, which is located over here, to then kind of dispatch the appropriate event to the appropriate method or function that we actually have here. And we'll take a look at that in a minute. So we'll set the event callback to actually be this specific event. And the way we can do that is just by using the standard bind. And we'll bind application event. You could create a macro for this. I usually end up doing that. onEvent. That ends up making things easier, especially with this whole placeholders thing. But for now, I think that's probably fine. I'll show you what I mean anyway. We might as well do it. You know, bind event function or something. Just becomes something like we just wrote, except we can just take an X here. And so this line of code becomes bind event function onEvent, and that's it. Obviously, something like this only works in the context of this class, but you can actually take this whole thing out if you want, and then this would just be application onEvent, which might be even nicer. So just something to consider. Anyway, I'm going to just go back to this. Okay, cool. So we've set up the event callback. The event callback goes into this window data struct that we have here. So if we call event callback, now that we've kind of set it up, it's actually going to end up calling this onEvent function. For now, let's just go ahead and print it. So I'll do hz info, hz core info, e. Okay, and then, or rather we have to provide formatting string, so we'll do that, and then E. So we're just printing the event, and because we have a toString implemented on every event, it should just print some nice details about what kind of event it is and what the data is set to. Okay, great, so now let's actually set up the events. So I'll write a nice comment here that basically just says set GLFW callbacks, because we're going to grab some callbacks from GLFW and we're going to just set them up. So we'll do the window size callback first. So we need to pass in the window and then a function that actually will get called whenever the window size changes. So for this, all we really need to do is, I'm just going to use a lambda. I'm just going to create a lambda which takes in a GLFW window, and then I think the best way to really do this is just to go to the callback function and just to go to this actual window size fun and see what it actually is. So you can see it's the window point and then two integers, and these two integers are the width and height. So we know that it's the window and then the width and then the height, and then we can have the actual implementation written here. So how do we now inside this lambda end up calling this application function and also creating the right event? That's kind of the meat of this function. So first of all, you might recall that we set a window user pointer. What this means is that onto this window kind of GLFW window is this kind of struct here that is defined somewhere that has basically like a spot for us to put any kind of data we want. In the form of this window user pointer, right? So it's just a void pointer. It can be pointed to anything. We've set it to be a pointer to this data struct that we have here, which contains all this data. So basically what that means is that inside this function, since we have access to GLFW window, we can just kind of get the user pointer, get window user pointer from the window, right? That returns a void pointer. So now we need to cast this to be the correct type, which for us is window data, because that's what we've set the user pointer to be. So we just need to do window data reference data equals window data like that, and then we're just dereferencing it here. Okay, there we go. And then we actually need to make the Hazel event. So we write window resize event, event, and then I think we just need to take in the width and height, and that's it. Now we need to include all of these events. So Hazel core, or just Hazel events, application event. Well, we need all of them anyway. So we might as well include them now. Mouse event and application event. Okay, cool. So there we go. So we've made that. Now we can dispatch it by just doing data.event callback with the event. But then we also have inside our data a width and height that is maintained kind of by the window, right? So we also need to set that up. So we'll say data.width equals width and data.height equals height. Cool. So we've created a window resize event, we've dispatched it, and then we've done all this. I might actually do this first, just so that we basically, even before we create any kind of event stuff, the window already has the updated size, because just hypothetically speaking, if inside one of these event kind of handling functions, we decide to query the window for its width and height, it would be wrong because it hasn't updated yet. So this way it's just a little bit better. Okay, and that's it. And you can see this kind of the same pattern that we have here is just repeated for every kind of event type. GLFW set window close callback as well just becomes, I think this is quite simple. I think this is just a window pointer and that's it. And then if this happens, we'll copy this line, and all we need to really do is create that window close event and then dispatch it. So data event callback event, and that's it. So next one, I probably don't really need to copy it. Next one we'll do is the key callback. So we'll set the key callback to be in window, and then the callback function, which we'll probably need to copy. So again, we'll go into here, we'll go into the key function, and then we have window and then 4 integers. So key, scan code, action, mods. So key, scan code, action mods. And then again, we'll grab this window data. Now, what we need to do at some point, by the way, is because this key code is kind of GLFW specific, we need to convert it into a Hazel key code, because on other platforms where we don't use GLFW, we don't want to be tied to those kind of key codes. We want to have our own. So at some point, we need to do some kind of conversion. So this one's going to be a little bit more complicated than the other ones. We basically want to switch on the action, because GLFW provides us with a bunch of different actions. There's something called press, there's something called release, and then there's something called repeat as well. So press, release, repeat. In the case of press, and we'll probably have to surround this in brackets as well, because we'll make a bunch of variables with the same name. So key pressed event gets created here, and then the key is what we pass in, as well as the repeat count of 0. So the key being the key code of the key that was pressed, and then we'll just call the event callback there. Repeat is going to be the same, except GLFW doesn't actually provide us with a repeat count, even though the Win32 API can do that. So we'll just set this to 1 for now. If we want that in the future, it's possible to extract. So we'll kind of keep that in mind. And then release is just key released event. And then we obviously don't have a repeat count for that. Okay, there we go. That is what we need to do. I like to indent this though, just so that it's a bit more clear. So we'll do that, and there we go. Cool, and that's all we need to do for the key callbacks. So the next one we'll move on to is the mouse button callback. This is basically the same as a key callback except for mouse buttons. So I think this one, yeah, just has 3 integers. So the button, the action, and then the mods. So window button action mods. So we'll grab this again. You guys can kind of see how maybe why I like to actually have the code written beforehand and then just kind of show you the diff, because I think it's a little bit less time wasty. But anyway, for this video I thought I'd type it out because it's not that much code. So we'll switch on the action, and again, mouse presses and releases are handled the same way. So we have the press event and the release event. We don't have repeat events. So mouse button pressed event. So the button that was pressed is really all we need. And the event callback. Mouse released event, same thing, except this is obviously on release, and that is it for mouse buttons. And then we have 2 more. We have the mouse position and the mouse scroll as well. I'll do the mouse scroll first. So set mouse scroll, or what is it? Set scroll callback. I think this just has 2 doubles. Yep, so 2 doubles, which is the X offset and the Y offset of the scroll. So int X offset, int, oh sorry, they're doubles. Okay, and then we grab this again. Whoops. And then we make a mouse scrolled event. We can pass these to floats. And then dispatch it. Okay, and then finally, we have our cursor position callback. Scrollback, I was gonna say. And then that, of course, is just whenever the mouse moves, we can get a callback with the position of where it is now. So this is just X position and Y position. And I think they were doubles, actually. Were they? Yeah, they were doubles. Okay, so we have two doubles. I think we just have them as either ints or floats, which should be fine. So cursor position callback, X position, Y position, grab this again, and then this is just a mouse moved event. What do we actually have here? Yeah, two floats. So we'll cast them to float as we did with the scrolling. And then we'll just call this. And that's it. That's all of our events implemented. So now, one more thing that I actually want to add is a GLFW error callback. So the other kind of type of callback that GLFW actually does, and I think we'll do this inside here, as soon as we initialize GLFW, is we can actually set an error callback. And I'll set this to be like an actual kind of function. So we'll just call it GLFW error callback. And we'll make this function up here. It'll just be a static function for now. But this is just going to be GLFW error callback. I think the error callback function takes in an int and a const char, so the error and then a description. So we'll pop that in here. Error description. And then all we'll do for now is just log it. So we'll say hset core error, GLFW error, and then I think maybe put this in brackets because that's the error code. And then we'll put the description. So error and then description. Okay. So we've now got an error callback as well. Okay, anyway, that is done. That is everything that we need to do here. So now what we should be able to do is just kind of run this, and we should, back in application, get every single event being logged. So let's go ahead and try that. Okay, so here is the engine, and then here we have our log. I'll kind of show the log here. You can see that when we move the mouse, we get the position of the mouse. When we click, we get button pressed and released event, and depending on which button is pressed as well. If I type, we get key released. If I hold down the thing, it says, you can see the repeat is set to 1. And then what else can I do? Scroll, resize the window. You can see how that works as well. It's quite nice. And then for close, we should get a close event. And you can see we do. It says window close. Okay, cool. So now let's implement that close event and also show you guys how the dispatcher works. Because I think there were quite a few questions on how to actually use the event dispatcher, and it's very, very easy. So over here, we'll stop logging all of our events. Actually, we'll kind of keep that in there just for debug purposes for this build, I guess. I think we're doing it, yeah, as info. Maybe let's do it as trace, because that way it's not green. And then we'll just do event dispatcher. We pass in the event. Now we know that for a window close event, what we essentially want is, and we'll kind of probably write this down here, what we actually want for a window close event is just a bool on window closed, and then window close event. I guess we'll call it on window close. Window close event E. That is basically the signature of kind of an event function, right? We'll go ahead and implement it. Bool application on window close event. I might actually move this to below run because we probably want to see run more than we do want to, than we actually want to see that. And then this will return true, I guess, because it's been handled. But basically we'll just set running to false, and that should obviously terminate this loop. At the next point that this is queried, rather, it will see that it's false, terminate the loop, and then that way we have nothing else to run in our application, and it should close. So to dispatch that, all we need to do is say that, hey, dispatcher, so we've created a dispatcher. Now we just say, dispatcher, if you see a window close event, right, then dispatch it to this function. Now we can use this bind event function we had before to bind a function to this. You could just create a lambda like I did with the other stuff, that's totally fine. Usually though, you probably want to actually have a function. So we'll do bind event function and then on window close. And obviously we're already inside the application namespace because it's in the macro. That's it. That's all you have to do. So what will happen here is that if this event that comes through is a window close event, right? And it does that by checking the type over here. It checks to see if the event type of the incoming event is equal to the static type of the template that you used here, right? Which you can do by just calling, T, which in this case is window close event, get static type, because you can see that obviously the window close event implements event class type, which implements get static type as the type of window close, right? So if that comes in, then it actually will call this function, which in this case is this, and set running to false. So let's hit F5 and see what happens. Okay, so we got a bunch of errors, and it's probably just because of not including stuff. So we have application event included here. I might move that to here because it doesn't know what window close event is. Let's hit F5 and hopefully this will work. Okay, there we go. So we have all the mouse move events are down. Everything is kind of tracing in the non-green thing, which is good. And now if I hit close, there you go, our application closes. So that is how we implement events. And this will be the basis for pretty much the events for the rest of the engine. So once we have layers and more of a better system for that, then the application will be in charge of actually dispatching those events further down. Because now the application, while having no knowledge at all of GLFW or of our window, right? Well, I mean, window doesn't have any knowledge of application. We just get a nice little callback with just the event, which is nice and clean and pretty cool. Alright, I hope you guys enjoyed this video. If you did, you can hit the like button. Leave any comments below as to what you think of this whole event system, because now we've kind of come to the conclusion, I guess, of implementing it. We had the planning stage, we had the implementation stage, and now we kind of have connected it to GLFW, to our window, and we have kind of the entire picture now of events in Hazel. So let me know what you think, if this kind of taught you something cool. I think that this is quite a nice, clean event system. I always love writing things like this. And really it is the basis for everything else. Because now if we decide that we want like a 3D camera or whatever, in our scene, we won't have to like be like, oh, but I don't have these certain events. As I mentioned with input though, we do still need to implement some kind of polling system where we can actually ask for the current state of things. We can't do that right now without using the GLFW API. So definitely we need to get onto that. And then there's also a huge list of things that I really want to do like right now. So next video is going to be a bit of a surprise, I think. If you guys want to support this series, you can go to patreon.com/thecherno. Huge thank you as always to everyone who supports that series. Next video for you guys, of course, is available as always. There'll be a link in the comments below. You'll get access to source code that's way ahead of this because I develop Hazel on a private branch, which I also use to kind of plan these videos. And in that branch, I kind of just develop it as fast as I can. So whenever I have free time or whatever, I can just write some code. And so we've got like IAM GUI in there. We've got OpenGL rendering. We've got like, it's way advanced. So definitely check that out if you are interested. Anyway, hope you guys enjoyed this video again, and I'll see you next time. Goodbye.